Hello there, welcome to the latest episode of the Data Radio Show, and thanks for tuning in, listening, downloading, watching, however it is that you're interacting with the content. I'm your host, Paul Barlow. Over the last couple of weeks, I've been really knocked out flat by the flu that's been doing the rounds at the moment. Here where I am in Aotearoa, New Zealand, it's the middle of winter, and that means cold and flu season, and I fell victim to it. But over the last couple of weeks, we've had a couple of interviews that were done by Sam Williams. He's an AI aficionado and a futurist. He sat down and chatted to the chief data scientist from Tech Data based out of Australia, Cheng Lan, and they had a look at some AI use cases because it's something that's, well, really, really popular at the moment. We actually recorded 3 of these sessions, so this is the 3rd of those sessions. I figured it's easier if we put them all out together so it's in one series, so if people want to jump through, they just need to go to the next one on the list to be able to access that particular piece of content. And this is one of the shorter ones. It's actually looking at using an AI assistant around things like the amount of carbon used in the creation and delivery of steel. It's a really simple sounding process, but for anybody who's ever worked in asset management, for example, you'll understand it could be quite complicated. So Shung runs us through how he's actually set up a bit of an AI assistant to help get this process underway. And again, it's just starting steps, but it's a great sort of use case to have a look at. Now, if you're listening to this in the podcast version, I'd recommend maybe jumping over and having a quick squiz at the video version on our YouTube page. And if you're watching this on the YouTube page, you can always download the podcast version from pretty much anywhere that you get your podcasts from. It's amazing how technology works like that. The problem is you can't get the video version on podcast, and there are some graphs and some bits and pieces of information that come through that might be easier to visualize if you can see them directly in front of you. Anyway, let's jump into that conversation, and I will talk to you guys at the end of it.
Yeah, it's funny. Your recording, you know how it got stuck at 99% trying to upload your recording last week? Well, all of a sudden, yesterday afternoon, it worked because spontaneously my computer just started playing the file because I'd left the window open waiting for it to happen. And it was like 5 days later. Like, I'm wondering what's going on in terms of this.
Wow, that is a long,
Yeah,
long time.
for 1%. It's like your
Yeah.
1%ers. Oh. All right.
Okay.
So we're recording. I will kick us off then. Hello and welcome to this Accelerate series on artificial intelligence use cases in the enterprise. Today we're going to present a use case for generative AI as an assistant for figuring out carbon footprint. So stay tuned to the end to hear about some of the substantial reductions in time to value when using large language models and GPTs. This series is brought to you by IBM Watson X and the folks at Tech Data, Certus Digital, and Ignition. I'm Sam Williams, host of the Intelligent Asset podcast, and today I'm joined by Sorry, I always trip myself up on your name. I go to pronounce it Cheng, so
That's good. The Cheng is good as well. Yeah.
I'm Sam Williams, host of the Intelligent Asset podcast, and today I'm joined by Shung Lang from. I'll try again. I'm Sam Williams, host of the Intelligent Asset podcast, and today I'm joined by Shung Lan, data scientist and AI specialist from Tech Data Australia, based in Melbourne and Victoria. Welcome, Sheng.
Thank you, Sam. Glad to be here.
Today, we wanted to show how generative AI has the potential to change the research process for carbon reporting. So much like having a university graduate at your disposal to perform research and help you develop a point of view, large language models and GPT agents can be applied to sifting through information to speed up the time to insight and develop value. To get us started, though, Shung, talk us through the process of pulling this use case together.
Let me bring this slide. Thank you. So for this idea, carbon data estimation is come from this digital labor concept, similar like you mentioned as an intern. So as we have in our daily work, we have some repeated task. It doesn't require a lot of thinking, but it's time consuming. So the digital labor here is to target to help to speed up that repeated task and really help people to focus on more important tasks. For this use case, we will estimate the scope 3 carbon data. So for scope 3 carbon data is like the CO2 emission from your purchase activities. And we have many practical guidance to show us how to do that. It's like a sequence of tasks you can follow to estimate for a specific purchase activity. So for today, we will follow one specific formula from U.S. government. The data we'll use for this estimate, we can see here is from U.S. government called greenhouse gas emission factors in 2021. And there is more than 1,000 different categories for product. And we can as use this as a lookup table to find the factors we can use to multiply the purchase price. Then will give us an estimate of CO2.
Okay, that's excellent. So just explain to the audience a little bit, Shung, how you would actually go about utilizing the specific use case that you had in mind. I believe it was around calculating the amount of carbon associated with a piece of steel. Is that right?
Yep. Yeah. So imagine the user scenario will be a worker to calculate this scope 3 report for all these purchase activities in like 1 year or last quarter. So there is a lot of think about the invoice data. So you will have different item on this invoice item in this invoice file. And for example, we will take a core and steel and how much we bought as an example. Here, we will show here is how the assistant to help us follow the sequence of tasks to do the calculation. The first step is to look up what is the factors for this corn, and it will find the information is what is the factor is. Then, well, what this part is to, since the data we have, the factor data we have is 2021, so it's kind of to consider the inflation and recalculate the purchase price in 2023. After we have this adjusted purchase price and also the factors, then we will do a multiply, use a calculator. So that how we get the corn calculation. Then we do the same for the steel. At the end, we can see the output here. That is how much CO2 emission for the purchase we did, and based on this sequence of tasks.
So again, how does this speed up time to insight? So this idea of having a research assistant. So it's not really automation that we're talking about here, because that's a number of repetitive tasks. But some of this process involves repetitive tasks that you can speed up. Make the distinction for viewers around the difference between automation and what generative AI research assistants are able to do.
Yeah, in my opinion, automation is like there may be no human involved. It just can't do that work for you. You just click the start button and you are expecting the outcome. For the generative AI assistant, it's more like to empower you, to help you to do the work more efficiently, to help you get information more quickly and get you to the right information. Consider the task we just demonstrated. You need to search a large spreadsheet and need to understanding, okay, for corn or steel, what category that belong to. And then you need to consider the inflation or how I calculate the inflation to adjust the money from 2021 to 2023, then do the calculation. So all this task is not, if we look at each of them, it's not very difficult, but it's time consuming. With generative AI, it will do that for you, and I'll show you how to do that. So you can just review that result and instead of do it by yourself.
Cheng, talk us through some of the time savings that are involved with using large language models and GPTs like this.
Yeah, of course. One of my experience when I worked as a consultant before, so we delivered a virtual assistant proof of concept that take us 16 weeks for a small team, 4 people. But for now, I think we can do that with much less time and less resource. So now I think we can do that same level of proof of concept in 4 weeks with the help of large language model, which is 75% reduction. Specifically, for example, the data science part. Before we need data science to identify what is the most popular topics in the data. Now with large language model, that capability is already in the model. So we don't need to do that specifically identify the intents. And also for the conversation flow, before we need to do that, basically to like a decision train to design that flow and develop that out. But for now, with large language model, it's more like a description, like to tell the model how you handle the conversation, then it will do that naturally and very quick. So with this large language model, we do see this significant reduction in time to impact, and also with this capability in large language model, and that empower myself and the team to do more with less time.
That's excellent. I guess this is the thing in terms of how business is speeding up as a result of engaging with generative AI, that, those moats that you used to have that were protective first mover advantage are being significantly eroded by the advent of generative AI. And so that's a key takeaway from this process. Not only is it helpful in terms of improving your personal productivity, but from a corporate competitive standpoint, it's changing up the game in terms of how quickly value can be delivered to customers.
Yep, totally agree.
All right. Well, that wraps it up for this particular session. Thanks so much for watching. If you'd like to see more, please like, comment, and also subscribe if you like what you're hearing here.
Hey, I want to thank Sam and Cheng for jumping in and recording that one for me. It's really fascinating to sit down and see that workflow process for somebody who is out there doing the hard work to make sure that AI tools are available for everybody in all kinds of ways that people might not necessarily realize. And I'd be really keen to hear in the comments section the sort of AI tools that you might be using within your industry or that you'd like to see developed. And maybe we could hook you up with somebody who can help you develop those tools. Anyway, don't forget as well to come and join us on our School community. School is a platform where you can basically earn points to get rewards and prizes and that kind of stuff, which we've built around data management. We're in the process of uploading a few new classrooms along the way, but there's already some classrooms there with content like this video, for example, will go into the School classroom. You earn points, you get on the leaderboards. It's really tough to win because I've been trying really hard to get up there. But I'll put a link to that in the description as well so everybody can pop along and check that one out. Until next week though, don't forget to like, share, subscribe, tell everybody about this video. Hopefully you learned something from it. And if not, well, there's plenty of other videos where there's lots there that you can learn from as well. So go enjoy those and I'll catch you guys all next time.